All right, these are the logic questions. These are tricky. So I'll try to talk slowly and hopefully you can walk through the logic with me. All right, so we have two charges that are glued down, a 10, a positive 10, and a positive 5. We care about the 10. Draw the force on the 10 caused by the 5. So the 10 and the 5 repel each other, so there's some force being pushing the 10 to the left. This is the force from the 5. Okay. Estimate the position at which you should place a negative 8 so that the 10 is balanced. All right, so this is the charge we care about. The 5 is pushing it to the left. We want the forces to balance, which means we want the negative 8 to pull it to the right. Since this is negative and that is positive, to pull it to the right, it means the negative needs to be somewhere over here. So that knocks out A. And 8 is bigger than 5. So the 8 needs to be farther away from the 5. Otherwise, here I'll do this. This is the wrong answer. If you put the 8, negative 8 here, the negative 8 is going to attract the 10 much more strongly because it's 8 is bigger than 5 and it's closer. Right, so it's got a really charged object really close to it. That force is going to dominate, and we don't want that to happen. So that is not going to work. So we have to put the 8 somewhere over here. We don't know where, but farther away, which is point E. The only option that's farther away is point E. So that is where we're going to put the 8. And so that the 10 says, I like the 8, but I like you equally. The 5 is weaker, but it's closer. The 8 is stronger, but it's farther away. And so the forces can balance. All right, question 4. Same setup just to save you some time. So the 10 is repelled by the 5. Now we want, instead of having the forces cancel, we want the net force on the 10 to be, we want the 10 to be pushed to the left as much as possible. So if I want to, since this is negative, if I want to push it to the left, I need to put the 8 over here so it'll attract it and help that force to the left. So the answer is A, but you can check your work. The 10 really, really likes the 8. I guess 8's not that much bigger than 5, but a little bit bigger than 5. So the 8 is pulling it to the left, and the 5 was already pulling it to the left. Since they're working together, that is going to create the biggest net force to the left. Okay, same scenario. Now we are going to move the -8 so that the 10 feels the greatest net rightward magnitude. And it might be impossible, right? Because it's being pushed to the left. We might not be able to, the 5 may just win no matter what we do, right? That's why I think it says, if it's impossible, choose letter F. Okay, so we want to pull 10 to the right. So in order to cause the biggest force to the right, we want the biggest force possible. Too bad we only have a -8, right? That's given. But what we can do is move it as close as possible, which is point B. So we're going to put the -8 as close as we can to the 10 so that the 10 is as really, really attracted to it. Okay, so we don't know how much it is, but we know that since the 8 is bigger than the 5 and it is closer, that this pink vector is going to be bigger than the orange vector. So the correct choice is B. To pull it to the right, get that -8 as close to the 10 as possible. Okay, so you have these two charges glued down. We care about the 15. So first draw the force on the 15 caused by the 5. So these two repel each other. So the force from the 5 looks like this. where would you place a charge that is negative and twice as big to cause this to be in equilibrium? Okay, so in order to be in equilibrium, we need to pull. This is what the force from the 10 needs to look like. It needs to be pulling it to the right. Since this charge is negative, that means we need it to be in region B, C, or D, right, to pull it this way because they attract each other. So that knocks out region A. And we want the forces to balance. So if we put the 10 in region B or C, it's both bigger in charge, it's twice as big, and closer. So that purple vector is just going to dominate the red vector. Can't. So what we need to do is put the minus 10 microcoulomb somewhere in D, right? And that's a solve for X problem that we don't want to do. This is just a way to test your logic without having to do LA algebra. So we need to put the 10 somewhere here so that it will pull the charge we care about to the right and be farther away than the 5 is so that it doesn't dominate, right? So 5 is less charged but is closer. 10 has more charge but it's farther away. So the answer is somewhere in region D. Okay, question 7 says, now we care about the 5. All right, so the 15 is still there. We care about the 5. The 5 and the 15 repel each other. So the 5 feels a force from the 15, some number of newtons. Okay, and we put the 10 somewhere in region D. So there's a minus 10 charge here. And we want to see, now we care about the 5. So the 5 is repelled by the 15, and the 5 is very much attracted to the 10. Because these two are opposite, so it's going to be, it's attracting the 5. So we got two forces to the right, so it is obviously directed to the right. Because they're both pulling it right. One by repulsion, one by attraction. All right, last question, I think. So 3 charges are glued down. The positive 8's at the origin, minus 12 is somewhere farther down the x-axis, and then some unknown charges at y. We know that the 8 feels a net force to the right. So the combination of the pushes and pulls from this guy and that guy is to the right. And then we want to see which of the following could be at point y. So this is kind of tricky. All right, so let's start with what we know. The 8 and the 12 like each other. So there already is a force of attraction between the 8 and the 12 to the right. I don't know if it's bigger than the green. I'm just trying to, not get in the way. Okay, so let's see what happens. I think this is just kind of trial and error. So if we put a positive 5, here, that will repel the 8. But since 5 is less than 12 and farther away, the force of repulsion from the 5, we know is going to be less than the 12, right? Because it's both weaker and farther away. So the orange vector is going to be bigger than the pink vector for sure. We don't know by how much, but that could work. Okay, what about if we put a positive 12 there? You might think, oh, that's not going to work because these have the same sign. But because this negative 12 is closer, it's going to pull on the positive 8 stronger than this one is. So this force of repulsion is going to be bigger because it went from 5 to 12. But it's still going to be less because this 12 is farther away than that 12. So it can't pull as hard because it's farther away. Right? So we're still going to have a net force to the right. All right, then what happens if we put a negative 5 at y? Then that is going to attract the 8. So we've got two forces of attraction. They're both going to the right. So that is going to cause a net, no question, that's going to cause a net force to the right. And then if we put a minus 12 microcoulomb there, that's going to attract it even more. Sorry, not as much as the orange, but more than before. So this minus 12 is pulling, this minus 12 is pulling, and so we clearly also have a net force to the right. All right, so I know nobody likes the answers, none of the above or all of the above, but they all happen to work. Okay, just quickly, if you're interested, what wouldn't work, let's see what an answer might have been that you wouldn't have circled. So again, the minus 12 is attracting the 8 with some force. If we wanted to make the net force go to the left, then what we would need here is some huge, let's say 330 microcoulomb positive force that's going to push the 8 so hard to the left that at some point it's going to be bigger than the pink force, and the net force is going to be the left, right? So the problem, none of these were big enough to overcome the 12 because the 12 is closer. All right, those logic questions are kind of tricky. Hope this helped, and thank you for listening.